In 1942, the German High Command believed they had solved the invasion problem before it even began. Along the western edge of Europe, from the rocky cliffs of Norway to the beaches of the Bay of Biscay, they poured concrete into the coastline and called it the Atlantic Wall. Gun batteries were sealed inside reinforced bunkers. Artillery pieces were positioned to cover every major harbor. Machine gun nests overlooked every stretch of sand that could support a landing. To Adolf Hitler, the lesson of history was simple. No army could invade a continent without first capturing a port, and every port that mattered was now a fortress. The logic seemed unbreakable. Modern warfare ran on fuel, ammunition, vehicles, and food. An invading force would need tens of thousands of tons of supplies every single day. Beaches alone could not handle that scale of unloading. Waves, tides, and weather would tear apart ordinary landing craft. Trucks could not roll directly onto sand in sufficient numbers. A deep-water harbor with cranes and sheltered docks was considered essential. Without one, an invasion would starve before it could break out inland. German planners were so confident in this assumption that they focused their strongest defenses around the major ports, Cherbourg, Le Havre, Brest, Calais. They believed that if they held the harbors, they held the continent. Even if the Allies landed somewhere unexpected, they would be forced to attack and seize a port within days. And that, the Germans were certain, would give them time to counterattack and drive the invaders back into the sea. But across the English Channel, British and American planners were wrestling with a brutal mathematical reality. By 1943, preparations for a cross-channel invasion were accelerating. The operation would require landing over 150,000 troops on the first day alone. Within weeks, that number would climb into the millions. Each soldier needed food. Each tank required fuel. Every bullet fired had to be replaced. The planners ran the numbers again and again. The daily supply requirement would reach thousands of tons, then tens of thousands. The question hung in every meeting room: where would it all be unloaded? The memory of Dieppe haunted them. In August 1942, Allied forces had attempted a raid on the French port of Dieppe. The objective was partly to test German defenses and partly to learn what a future invasion might require. What happened instead was a disaster. Canadian troops landed directly against a fortified port. German machine guns cut them down on the beaches. Tanks became trapped on the shingle shore. Within hours, the raid collapsed. Of nearly 6,000 men who landed, more than half were killed, wounded, or captured. The lesson was written in blood. A defended port could not simply be stormed and taken intact. Yet without a port, invasion seemed impossible. It was a paradox. Attack a port directly and suffer catastrophic losses. Avoid the ports, and your army would wither from lack of supply. British Prime Minister Winston Churchill understood the dilemma clearly. So did American General Dwight Eisenhower and the Supreme Headquarters Allied Expeditionary Force. Intelligence reports confirmed that the Germans had spent years fortifying every major harbor along the French coast. Concrete thickness was measured in meters, gun emplacements were camouflaged and interlocked, minefields guarded the approaches. The Atlantic Wall might not have been continuous, but its strong points were formidable. Allied intelligence also revealed something else. The Germans expected the invasion to target the Pas de Calais, the narrowest point between Britain and France. That assumption would later become central to Allied deception plans. But even if surprise could be achieved, logistics could not be fooled. Supplies had to move, ships had to unload. The numbers did not change. Inside planning rooms in London, officers covered tables with maps and tide charts. Engineers debated wave heights and seabed gradients. Naval experts studied weather patterns in the English Channel, notorious for sudden storms. Some argued that capturing Cherbourg quickly was the only viable option. Others warned that even if taken, a port could be demolished by retreating German forces before it could be used. Intelligence suggested the Germans had prepared demolition charges in many harbors. A captured port might be nothing more than a field of twisted steel and sunken ships. The deeper they studied the problem, the clearer it became. Relying on an intact port was a gamble they could not afford. At some point in late 1942 and early 1943, the conversation shifted from what was practical to what sounded absurd. If they could not seize a port, could they build one? The idea was not entirely new. Temporary piers had been constructed in previous conflicts, but nothing on this scale had ever been attempted. The proposal was staggering. Construct massive harbor components in Britain, tow them across the English Channel after the invasion, and assemble them off the beaches of Normandy. Floating roadways, concrete breakwaters, adjustable piers that could rise and fall with the tides, an artificial harbor where none had existed the day before. Many dismissed it as fantasy. The Channel's tides could rise and fall by more than 20 feet. Storms could rip apart even permanent structures. Concrete caissons large enough to block waves would weigh thousands of tons each. How would they be floated? How would they be anchored? How would they survive enemy fire? Yet the alternative remained worse. No port meant no sustained invasion. No sustained invasion meant no liberation of Western Europe. Engineers began sketching designs in secrecy. They imagined hollow concrete blocks, sealed and buoyant, that could be sunk in position to form breakwaters. They designed floating steel roadways that could flex with the waves, yet support heavy trucks and tanks. They calculated towing speeds and assembly times. They tested scale models in basins and laboratories. Gradually, what sounded impossible began to look merely improbable. The Germans, watching the English coastline through reconnaissance flights and spy reports, saw shipyards busy and factories active, but they did not see a harbor being built piece by piece behind guarded fences. They did not imagine that their core assumption that an invader must capture a port was about to be challenged in the most literal way possible. By early 1944, the decision was made. The invasion would land on open beaches in Normandy. Ports would not be seized on the first day. Instead, once a foothold was secured, an entire artificial harbor would cross the sea. It was given a code name, Mulberry. What had begun as a desperate question had become a revolutionary answer. If the enemy fortified every harbor, then the solution was simple in concept and staggering in execution. Bring your own. By early 1944, the invasion plan depended on an idea so bold that even some of its supporters struggled to believe it would work. The codename was Mulberry. On paper, it sounded deceptively simple. Build 2 complete artificial harbors in Britain, tow them across the English Channel after the landings, and assemble them off the beaches of Normandy. In reality, it was one of the most complex engineering operations ever attempted in wartime. The driving force behind the concept was Winston Churchill. As early as 1942, he had written a memo insisting that preparations must begin for portable harbors. Piers for use on beaches, he demanded, must float up and down with the tide. It was not a suggestion, it was an order. Churchill understood that the invasion would live or die by logistics. If soldiers could land but supplies could not follow, the entire operation would collapse within days. The responsibility for turning that demand into reality fell to British engineers, naval architects, and thousands of civilian workers. The project was wrapped in intense secrecy. Construction sites were scattered along the British coastline at places like the Clyde, the Thames estuary, and the Solent. From the air, they appeared to be ordinary shipbuilding or civil engineering works. In truth, they were producing the pieces of a harbor. At the heart of Mulberry were the Phoenix caissons, enormous, hollow concrete blocks, some as tall as 5-story buildings and weighing up to 6,000 tons. Each one was designed to float when empty, towed slowly across the channel, then sunk deliberately in position to form a massive breakwater. When aligned side by side, they would create a sheltered basin where ships could unload safely, protected from waves and swell. Building them required staggering amounts of material. Britain, already under wartime strain, diverted cement, steel, and skilled labor to the project. Over 45,000 workers contributed in one way or another. Many had no idea what the final purpose would be. They poured concrete into giant molds. They installed valves and flooding systems that would allow the caissons to be submerged with precision. Every measurement had to be exact. If a caisson cracked or listed during towing, it could block a channel or sink in the wrong position. But the breakwaters alone were not enough. Inside the sheltered water, ships needed piers where they could dock and unload cargo. For that, engineers designed floating pierheads mounted on massive steel legs known as spuds. These legs could be lowered to the seabed, anchoring the platform firmly while allowing it to rise and fall with the tide. The English Channel's tidal range was extreme, sometimes more than 20 feet. A fixed pier would be useless within hours. The Mulberry pierheads had to adapt continuously. Connecting the pierheads to the shore were the floating roadways, known as whales. These were long steel spans mounted on pontoons, flexible enough to bend with the waves, but strong enough to carry the weight of fully loaded trucks and even tanks. Designing them was a balancing act between strength and movement. Too rigid, and they would snap in rough seas. Too flexible, and heavy vehicles would tear them apart. To further calm the waters, engineers developed floating breakwaters called bombardons. These cruciform steel structures would be anchored offshore, reducing the force of incoming waves before they reached the Phoenix caissons. Every component had to work together. If one failed, the entire harbor could be compromised. Testing was relentless. Scale models were placed in wave tanks. Full-sized sections were trialed along British beaches. Engineers observed how the structures behaved under stress, making adjustments and reinforcements. Failures were analyzed in detail. Time, however, was always the enemy. The invasion date was approaching, and the harbors had to be ready. German intelligence, despite its extensive spy networks, failed to grasp what was happening. Reconnaissance flights detected unusual construction along the British coast, but the purpose was unclear. Some analysts speculated about floating docks or defensive structures. Few imagined that the Allies intended to tow entire sections of a harbor across open sea and assemble them under combat conditions. The assumption remained fixed in German strategic thinking. Any serious invasion required capturing a port. Meanwhile, British and American planners coordinated the final details. 2 Mulberry harbors would be built, one for the American beaches at Omaha and one for the British and Canadian beaches near Arromanches. Timing was critical. The components would begin crossing the channel immediately after D-Day once a foothold was secured. Tugboats would pull the massive caissons at slow speed, vulnerable to weather and enemy attack. Naval forces would provide protection. Engineers would assemble the harbor in stages, often working around the clock. The scale of coordination was extraordinary. Hundreds of vessels were assigned towing duties, specialized crews trained in flooding and anchoring procedures. Detailed charts marked exact seabed positions where each caisson would be sunk. There was no margin for chaos. Invasion beaches were already crowded with landing craft, warships, and supply vessels. The arrival of the Mulberry components would add another layer of complexity to an already immense operation. As spring turned to summer in 1944, the artificial harbors waited along the British coast like silent giants. From a distance, they looked like rows of concrete fortresses floating calmly at anchor. Soon, they would face the unpredictable waters of the Channel and the uncertain violence of war. What began as a desperate solution to an impossible problem had become a physical reality. Thousands of men and women had turned imagination into steel and concrete, and within weeks, Those floating structures would attempt something no engineer in history had ever tried, to create a working deep-water harbor on an open, hostile shore in the middle of the largest amphibious invasion the world had ever seen. Before dawn on June 6, 1944, the largest amphibious armada in history was already moving toward the coast of Normandy. More than 5,000 vessels, warships, transports, landing craft cut through the cold waters of the English Channel. Operation Overlord had begun. But hidden among the preparations for D-Day was another operation that would unfold in its shadow, one that would determine whether the invasion could survive beyond its first fragile hours. The initial landings were brutal. At Omaha Beach, American forces faced devastating fire from German defenses positioned on high ground. Casualties mounted quickly. On other beaches, Utah, Gold, Juneau, and Sword, the situation was uneven but gradually stabilizing. By the end of the first day, the Allies had secured a tenuous foothold. It was enough. The signal was given. Mulberry would move. Within hours, tugboats began towing the massive Phoenix caissons out of British harbors. These concrete giants, some longer than a city block, moved at barely walking speed across the channel. The journey was dangerous and slow. Each caisson had to remain stable in shifting currents and unpredictable weather. A single structural failure could send thousands of tons of concrete to the seabed in the wrong location, or worse, block the approach lanes needed for the invasion fleet. Alongside the Phoenix units came the bombardons, the floating breakwaters designed to absorb wave energy offshore. Steel roadways, pierheads, pontoons, anchoring cables, hundreds of individual components were scattered across the sea, each assigned a precise destination off the Normandy coast. The English Channel, already crowded with naval vessels and supply ships, became a floating construction site. German forces initially struggled to comprehend what they were seeing. From coastal observation posts, they reported unusual maritime activity. Large concrete structures appeared on the horizon. But by then, the invasion front demanded their full attention. Counterattacks were being organized inland. Artillery duels raged along the beaches. The artificial harbors were assembling in the middle of chaos. At Omaha Beach, American engineers worked to position the first line of Phoenix caissons. Tugboats maneuvered them carefully into alignment. Then valves were opened. Seawater rushed into ballast chambers. Slowly, deliberately, each caisson settled downward, touching the seabed and locking into place. One by one, they formed a protective arc, a barrier against the open sea. Behind them, the water calmed. Simultaneously, at Aramash, in the British sector, construction crews labored under constant pressure. Timing was everything. The components had to be connected in sequence. Pierheads were anchored to the seabed using their spud legs. Floating roadways were bolted into position, stretching from shore to the waiting platforms. The entire system had to adjust to tides that rose and fell dramatically each day. Men worked around the clock. Sleep was scarce. Equipment was scarce. In some cases, German artillery fire reached the construction zones. Naval vessels provided covering fire, while engineers tightened bolts and secured cables. The beaches were still active combat zones, yet within days, the outline of two working harbors began to take shape where only open water had existed before. The scale was unprecedented. Never before had entire port facilities been fabricated in one country and installed in another under combat conditions. By June 9th, only 3 days after D-Day, the first ships were unloading cargo through the partially completed Mulberry harbors. Trucks rolled along the Wales, engines humming as they carried ammunition, rations, and fuel directly onto French soil. For the soldiers fighting inland, the difference was immediate. Supplies that might have taken days to unload by primitive beach methods were now moving steadily and efficiently. Tanks could disembark without grinding through unstable sand. Artillery pieces were brought ashore in larger numbers. The invasion force, once vulnerable to running out of fuel and ammunition, began to gain logistical momentum. Yet the operation remained fragile. The American Mulberry at Omaha, Mulberry A, was still incomplete. The British harbor at Arromanches, Mulberry B, was progressing more smoothly, benefiting from slightly calmer waters and fewer initial setbacks. Every tide tested the anchoring systems. Every swell strained the joints of the floating roadways. Engineers constantly inspected for cracks, shifts, and weaknesses. By mid-June, both harbors were functioning. Ships lined up offshore, waiting for their turn to enter the protected waters. The vision that had seemed like a fantasy only months earlier was now reality. An artificial port, fully operational, supporting the largest invasion force in modern history. But the channel had one more test in store. The weather forecasts began to shift. Barometers dropped. Experienced sailors grew uneasy. A storm was forming, one that would strike Normandy with unexpected violence. The harbors had survived enemy fire and the complexity of assembly. Now they would face something far less predictable and potentially far more destructive, the raw force of the sea itself. On June 19, 1944, less than 2 weeks after D-Day, the sky over Normandy darkened. The wind began to rise, first as a steady pressure, then as violent gusts that whipped across the channel. What followed was one of the worst summer storms to hit the region in decades. For 3 days, from June 19 to June 22, the sea turned savage. The timing could not have been worse. The Mulberry harbors were still new, still settling into position. Anchors had been tested, joints tightened, weaknesses patched, but nothing like this had been anticipated so soon. Waves crashed against the bombardons offshore, twisting the floating steel breakwaters. Swells rolled inward, hammering the lines of Phoenix caissons. The floating whales rose and dropped violently, their steel joints groaning under the strain. At Omaha Beach, Mulberry A faced the full force of the storm. American engineers watched as mooring lines snapped, one after another. Bombardons tore loose from their anchors and drifted, some colliding with other structures. The carefully aligned Phoenix caissons shifted under relentless pressure. Sections of floating roadway broke apart, steel spans bending and sinking into churning water. Ships caught inside the harbor struggled to maintain position. Some were driven against the concrete breakwires, others ran aground. The storm did not pause. It battered the coastline without mercy, hour after hour, tide after tide. When the winds finally began to ease, the damage was catastrophic. Mulberry A was shattered. Large portions of the American harbor lay twisted and submerged. Roadways were broken beyond quick repair. Several caissons had moved out of alignment. The protected basin no longer offered reliable shelter. In practical terms, the harbor was no longer operational. For the Allied command, the implications were terrifying. The invasion front was expanding inland, but supply lines were still fragile. Without the American Mulberry, could the beach sustain the required flow of fuel, ammunition, and reinforcements? Thousands of tons of supplies were scheduled to arrive in the coming days. Now the infrastructure meant to handle them was crippled. Emergency meetings followed. Engineers assessed what could be salvaged. Some argued for full reconstruction. Others warned that the time and resources required would divert critical assets from the advancing army. The sea had delivered its verdict. Mulberry A would not be rebuilt. Instead, American forces shifted to an intensified beach unloading system. Landing ships were driven directly onto the sand at high tide and unloaded as quickly as possible before the water receded. It was less efficient and more chaotic, but it worked. The beaches became enormous logistical hubs, operating almost continuously. What had once been considered impossible, supplying a major army over open beaches, was now done out of necessity. Meanwhile, at Arromanches, Mulberry B endured the same storm, but with a different outcome. The British harbor suffered heavy damage. Several bombardons broke free. Sections of roadway were lost, but the core structure held. The Phoenix caissons remained largely in position, forming a protective crescent against the sea. The pier heads survived. When the storm subsided, engineers moved immediately to repair what they could. Replacement spans were installed, anchors were reinforced, damaged components were cleared. Mulberry B was wounded but alive. Within days, it resumed full-scale operations. Ships once again entered its sheltered waters. Cargo flowed across the floating roadways onto waiting trucks. The artificial harbor at Arromanches became the logistical heart of the Allied invasion. In retrospect, the storm revealed both the vulnerability and the resilience of the Mulberry concept. It proved that nature could destroy even the most ambitious engineering project. But it also demonstrated adaptability. The Allies did not collapse when Mulberry A was lost. They improvised, adjusted, and continued pushing inland. By late June, the supply situation stabilized. The beaches handled more traffic than planners had originally believed possible, and Mulberry B increased its throughput, compensating for the American loss. Every day that passed strengthened the Allied position in France. German counterattacks failed to break the growing bridgehead. Ironically, the Germans never fully grasped how close the storm had come to disrupting the invasion. They had invested years fortifying ports, convinced that an attacker could not function without them. Yet even after losing one of their artificial harbors, the Allies adapted faster than expected. The gamble had not failed. The storm of June 1944 became a defining test. It stripped away the illusion that Mulberry was invulnerable. It forced commanders to confront hard decisions under pressure. And it confirmed a deeper truth. Victory in Normandy would depend not only on bold ideas, but on the ability to endure when those ideas were pushed to their limits. One harbor lay in ruins beneath the Channel's waves. The other stood firm, becoming more important than anyone had imagined. And as July approached, that surviving harbor would begin to handle a volume of traffic that would reshape the war in Western Europe. By July 1944, the surviving Mulberry Harbor at Arromanches was no longer an experiment, it was a lifeline. Every morning, ships lined the horizon of the English Channel, waiting their turn to enter the sheltered waters behind the crescent of Phoenix caissons. Cargo vessels, liberty ships, tank landing ships, one after another, moved into position beside the floating pierheads. Cranes swung into motion, trucks rumbled across the steel wails. Ammunition, fuel, food, artillery pieces, and armored vehicles poured onto French soil in a steady, relentless stream. What had begun as a desperate solution to a logistical paradox was now operating at a scale that even some planners had not fully imagined. Within weeks, Mulberry B was handling thousands of tons of supplies per day. The artificial harbor functioned continuously, day and night, tide after tide. It adapted to changing conditions. Sections were reinforced, damaged components were replaced. The system evolved under pressure. Behind the front lines, Allied armies were pushing through the hedgerows of Normandy. The fighting was slow and brutal. German forces resisted fiercely, using the dense bocage terrain to their advantage. Progress was measured in fields and villages, not miles. But unlike previous campaigns, the Allied advance did not stall from lack of supply. Fuel reached the tanks, artillery shells reached the guns, replacement troops arrived in growing numbers. By the end of the summer, the numbers told the story. Through the Normandy beaches, supported heavily by the Arromanches Mulberry, more than 2 million men would land in France. Nearly 500,000 vehicles followed. Millions of tons of supplies crossed the Channel. Much of that early critical flow passed through a harbor that had not existed before June 1944. German commanders gradually realized that their central assumption had failed. They had fortified every major port along the Atlantic Wall, convinced that the invader would have no choice but to capture one quickly. Instead, the Allies had bypassed the problem entirely. Cherbourg, when finally captured at the end of June, had been heavily sabotaged by retreating German forces and required extensive repairs. It was unusable at first. Yet the invasion did not falter because the Mulberry Harbor had already filled the gap. For 10 months, the Arromanches Harbor continued operations. Even after larger French ports were restored to service, Mulberry B remained active, handling cargo well into early 1945. Concrete caissons stood firm against repeated storms. Floating roadways flexed and endured. What many had dismissed as fantasy had become routine. The engineering legacy was profound. The Mulberry Project demonstrated that logistics could redefine strategy. It showed that mobility in modern war was not only about tanks and aircraft, but about ports, fuel depots, and supply chains. The success of the Normandy invasion was not determined solely on the beaches under fire, but in the planning rooms where engineers dared to challenge conventional limits. When historians later examined Operation Overlord, they often focused on the heroism of soldiers on D-Day, the airborne drops, the naval bombardment. Yet without the artificial harbors, those victories might have been temporary. An army without supply is an army on borrowed time. Mulberry extended that time indefinitely. Today, remnants of the harbor still rest off the coast of Arromanches. At low tide, parts of the massive concrete caissons remain visible, rising from the water like silent monuments. They are weathered and scarred, but unmistakable. They mark the place where imagination met necessity and prevailed. In the end, the story of Mulberry is not only about concrete and steel, it is about the refusal to accept an impossible equation. The Germans believed that no invasion could succeed without capturing a fortified port. Allied planners answered with a radical alternative. If you cannot take a port, build one, tow it across the sea, assemble it under fire, hold it against the storm. And in doing so, they changed the course of the war in Western Europe.